Welcome to Physics Made Easy channel. The topic that we shall now be covering is electron capture. Electron capture competes with the inverse beta decay. That's the reason why we are covering it. Now, some proton-rich nuclei capture one of the atomic electrons. A proton in the nucleus combines with the electron forming neutrons. A neutrino created in the process is emitted from the nucleus. So this is electron capture. Now what happens in electron capture will be clear from this diagram. For example, this is the nuclei. There are a large number of protons and this electron is now revolving around the nuclei, and the nuclei is heavy nuclei. This condition is must for this phenomena to take place. It's a heavy nuclei. Heavy nuclei. This is heavy nuclei. So it captures one of the electrons and emits. It captures one of the electrons and converts itself into neutron, and a neutrino is emitted. This neutrino is emitted. In this way, neutrino is emitted. Now, this is a heavy nucleus. So when neutrino is emitted, a vacancy is created here. At this point, electron was captured by the nuclei here. Electron was captured by the nuclei. This electron was captured by the nuclei and vacancy was created here. And an electron from L shell shifts to K shell. And difference of their energy in the form of X-ray is released. Now, it may be followed by release of another radiation because here now L shell, there is a vacancy in L shell. Vacancy has shifted to L shell and an electron from M shell may shift there and another photon may be emitted. Another photon may be emitted. In this way, electron capture proceeds. In this process, neutrino is emitted. Now, this is the general equation for entire process ZXA. It captures an electron and finally what we get is Y Z-1A plus neutrino. Neutrino is emitted. Now, if you shift this to this side, then it becomes inverse beta decay. If I shift this to this side, this is Z-1 YA plus 1 positron emission plus neutrino. In this way, these two reactions, they compete. Electron capture compete with inverse beta decay. So this has been asked once or twice. The process is called electron capture or K capture. Vacancy created in the K shell is filled by transition of electrons from outer shells. This results in emission of characteristic X-ray. This process goes on. The next is gamma decay. The process of emission of gamma ray photon during radioactive disintegration of the nucleus is called gamma decay. Gamma ray photon have no charge, possess zero rest mass. It is just energy. Gamma ray decay Gamma ray does not produce any change in mass number or atomic number. A general gamma decay is expressed like this. What we can write is ZXA. I will write here star. It means it's an excited nuclei and it prefers radiative de-excitation. So it emits a gamma ray photon. Normally, beta emission beta particle emission is followed by gamma ray emission. Is followed by gamma ray emission. Now, after emission of alpha or beta decay, daughter nuclei is usually left in excited state. It attains the ground state by single or successive transition by emitting one or more photon. It comes to ground state by emitting one or more photon. As the nuclear states have energy of the order of million electron volts, therefore photon emitted by the nuclei have energy of the order of several MeV. And the short wavelength electromagnetic waves emitted by the nuclei, they are called gamma ray. The basic argument is after the emission of alpha or beta particles, daughter nuclei are in excited state. Now they can de-excite in radiative way or in non-radiative way. If they de-excite in radiative way, then they emit radiations. But after beta ray emission, usually the energetically possible radiative decay is gamma decay. So gamma decay follows the emission of beta particle. Here we have got an example. This is 27 cobalt. I will write this reaction. 27 cobalt 60. It gives out 28 nickel 60 plus an electron, beta particle emission plus antineutrino. Now, this nuclei is in excited state. Now, energetically possible emission for this is E gamma is 1.17 million electron volt. First, it emits 1.17 million electron volt photon. It de-excites to this metastable state, another metastable state. And here it is still excited. And it gets de-excited by emitting a photon of energy 1.33 MeV. In this way, now this is a de-excited state or the ground state of nickel nuclei. So here we have seen that beta decay is followed by, here a beta particle is emitted by 27 cobalt 60 emits a beta particle. Daughter nuclei is 28 nickel 60. It is in excited state. It de-excites by emitting two successive photons. So this is how gamma decay takes place. In the next in consideration is this fluorine. This another reaction of gamma decay. Now here we have got 9 fluorine 20, it emits a beta particle and gets converted into 10 neon 20. From here, a beta particle is emitted, then an antineutrino is emitted. Now this is in excited state. This is in excited state. It de-excites by emitting a photon of energy 1.63 MeV. Now, whether the de-excitation is through emission of one photon or through emission of two successive photons like this depends upon transition rules and is beyond the scope of your syllabus. Next is we will study nuclear reaction. The topic of nuclear reactions is again a very paying topic. The questions asked from here is just you have to balance Z and A to conclude the particles, and this topic is very paying. Questions are asked from here in your NEET or your board examination, NEET examination, and JEE mains as well, but not in JEE advanced. Very rarely questions is asked in JEE advanced from this topic. In nuclear reaction is change of stable nuclei of one element into another element, usually caused by bombarding of nuclei with suitable high energy particles. If all the nuclear reactions studied so far, the following conservation laws are obeyed. First is conservation of total charge, number of nucleons, total energy, linear momentum, angular momentum, spin and parity. So these are the conservation principles. Conservation of charge means Z of the reactant should be equal to total Z of the products, means we will do it just now. And then the number of nucleons means A is conserved. This means Z is conserved. This means A is conserved. This means total energy E is conserved. And linear momentum P is conserved. Angular momentum L is conserved. All these are conserved. And then spin and parity. Spin and parity, they are also conserved. Spin and parity, I am denoting parity by P. So now first kind of nuclear reaction or alpha particle reaction, they are induced reaction. We call it alpha proton reaction. Alpha particle is bombarded on boron 5, 6 carbon 12 and 1 H2 deuterium, they are formed. Now let us verify Z number. So Z number in this case, Z here 5 plus 2 7, 6 plus 1 7, conserved. 10 plus 4 mass number, 10 plus 4 14 on left side and 12 plus 2 14 on right side. So they are also conserved. And now this is alpha neutron reaction. Nuclei is bombarded with alpha particle and neutron is emitted. This is 4 beryllium 9 is bombarded by alpha particle, 6 carbon 12 is the daughter nuclei plus this neutron. Now let us verify Z. Z verification 4 plus 2 6, 6 plus 0 6. So 6 on the left side, 6 on the right side. Now let us verify mass number A. 9 plus 4 13 on the left side, 12 plus 1 13 on the right side. So they were the one kind of reaction, induced reaction. Now reaction can be induced by alpha particle. Reaction can also be induced by deuteron. 6 carbon 12 is attacked by deuteron, bombarded with deuteron, nitrogen and neutrons, they are the products. You can again verify conservation of Z and N number. Conservation of Z is verified. 6 plus 1, 7, 7 plus 0, 7. So 7 on right side and 7 on left side. Now conservation of mass number A. 12 plus 2, 14. 13 plus 1, 14. On the same line, 6 oxygen 16 plus 1 H2 is equal to 7 nitrogen 14 plus alpha particle. This is D alpha reaction. So here deuteron bombards oxygen, we get nitrogen and helium. On the same line, lithium is bombarded by deuteron, we get proton plus lithium 8. 3 plus 1, 4, 3 plus 1, 4. 7 plus 2, 9, 8 plus 1, 9. Then proton induced nuclear reaction. P gamma reaction. So this 7 nitrogen 14 is attacked by proton 1H1. So we get 8 oxygen 15 plus gamma ray. And then P alpha reaction. These are the proton induced reactions. P alpha reaction. In P alpha reaction, what we get is this proton bombards lithium. This is lithium is bombarded by proton. We get 2 He4 plus 2 He4. We get 2 alpha particles. Similarly, PN reaction. Similarly, PD reaction. Let us check conservation of Z in PD reaction. 4 plus 1, 5. And 4 plus 1, 5. 9 plus 1, 10. 8 plus 2, 10. So mass number Z and A, mass number A and atomic number Z, they are conserved. Next are the neutron induced reaction, and after that gamma ray photon induced reaction. So these are gamma ray, gamma neutron, gamma proton reaction. So in this way we have covered the nuclear reactions. Now one should very diligently practice the nuclear reactions because they are very paying part in your examination. If you prepare them, you are definitely going to score marks. So in our present lecture, first we covered electron capture. In electron capture, we argued that in case of heavy nuclei, nucleus captures K shell electron and X-rays are emitted. And further, other radiations of low energy may also be emitted. In this case, neutrino is emitted. Neutrino plus X-rays, they are emitted, and neutron, it stays inside the nuclei. And after that we studied gamma ray, and we know that gamma ray are chargeless and massless. They are just photons of energy. So a nuclei in excited state de-excites by emitting gamma radiation, ZXA. Normally after alpha decay or beta decay, daughter nuclei are in excited state. Particularly after beta decay, if daughter nuclei are in excited state and they de-excite by emitting radiations, and then in case of beta decay, mostly gamma rays are emitted. We are taking 27 cobalt 60. Beta particle is emitted, nickel is in excited state. It de-excites by emitting 2 successive gamma ray photons. And then another example we have picked up of fluorine. Fluorine 9F20. It emits a beta particle, and here we have got 10 neon 20 in excited state. Then it de-excites by emitting a gamma radiation. In next part, we got nuclear reactions by one process when we bombard a nuclei with some particle. There are alpha P reaction. Alpha P reactions in which the bombarding particle is alpha and emitted particle is proton. So now there are some properties of nuclear reaction, and it obeys some conservation laws. The conservation laws obeyed are conservation of mass number A, conservation of atomic number Z, then total energy conservation, linear momentum conservation, angular momentum conservation, spin and parity conservation. So it weighs all these conservation principles. And after that, we have classified basically few reactions. For example, alpha particle reactions, neutron reactions, proton bombarded reactions, and then neutron induced reaction, and then gamma ray photon reactions. So in this way, we broadly covered the topic of nuclear reactions. And before ending this lecture, I will request all of you kindly comment if you don't like the video and share if you like it. With these words, thank you very much for being with me for 20 minutes.